an inverse function, okay? Let me get you started with this. First, what is the inverse? Okay? Well, let me remind you what a function is. Okay? A function, let's make a machine, and that machine is going to represent a function. Example. Here's a machine. This is the input, and this is the output. Okay? And this machine is a function. Let's call it f of x. F of x equals to 2x minus 3. It's a linear function. Okay? Note, we're going to pick values from the domain of this function that go in, and then values from the range of this function are going to come out. Okay? So what's the domain for this? Well, domain is all real numbers. You can plug in anything. So domain is R real numbers. Okay? And the range is also R. Okay? So look, we can send values into the domain, values from the domain into this machine. It's a machine. And then values from the range of this machine are going to come out. Okay? So, by the way, this function takes the value, takes whatever goes inside, so it takes the value, and 1 multiplies it by 2, and 2 subtract 3. Okay, multiplies it by 2, subtract 3. That's what this machine will do to anything that goes inside. For example, a 2 goes inside as a 2. And what's going to come out? Let me see. This machine is going to take the 2, multiply it by 2, 4, subtract 3, and a 1 comes out. And so note, understand that from that 2 going in and the 1 coming out, we have the point 2, 1. This is the point x and y for the function. This is an order pair for this function for f of x. Okay? All right. Let's send in another one. Okay, let's send in a 3. If a 3 goes in, what's going to come out? Let me see. 3 times 2 is 6. 6 minus 3 is 3. A 3 comes out. So now we have the point 3, 3. Okay? Let's send in another one. Let's send in negative 1. Negative 1. Negative 1 goes in. Negative 1 gets multiplied by 2. Negative 1 times 2 is negative 2 minus 3 is negative 5. A negative 5 comes out. And an order pair to this function is negative 1, negative 5. Okay? All right. So these are order pairs for the function f of x. This is f of x. And these are order pairs for this function. We have a 2, comma 1. We have a 3, comma 3. Let's send in one more. One more. How about negative 2 goes in? Negative 2. Negative 2 goes in, it gets multiplied by 2. That's what this function does. It gets multiplied by 2. So what's negative 2 times 2? Negative 4, subtract 3, negative 7. Negative 7. Okay? And so what order pair did we get? When we send in negative 2, we got the order pair negative 2, comma, negative 7. Okay? So this is what we did in the past with functions. Okay? You plug in an x value into the function will compute, and then comes out a y value. Okay? We call this the domain of the function, and this is the range of the function. Okay? Now, in section 5.2, we want to find a function that reverses this process. Yes. A function that reverses the process. This function is going to reverse the process. Okay? If it's going to reverse the process, it means that if you send in 1 into this function, you better get 2. So, because it's going to reverse the process, okay, we're going to send these values into this function, and we better get these values. That's how we know it's reversing the process. So here we go. So now this is the function that we're looking for, and this is in, and this is going to be what? Out. Okay? In and out. All right? So we're looking for a function that reverses the process. Once you find that function, we're going to call it the inverse function. Okay? That's going to be the inverse function. And we're going to use this notation. We're going to use f inverse of x. Okay? That's the notation we're going to use for the inverse function. Once we find it, we're going to call it the inverse function. Okay? Now, let me give you an example. Okay? We reverse the process every single day. Yes, we do. Every single day we reverse the process. Let me get my towel so that I can erase, okay? Give me a second. Okay. So we reverse the process every single day. And I'm going to show you how we reverse the process. Okay, watch this. This is how all of us reverse the process. In the morning, okay, in the morning, this is what we do. When we get dressed in the morning and we put on our socks and shoes, watch this. In the morning, the first thing we do is put on socks. And then, second, put on shoes. This is what we do in the morning. Of course, among other things, but I just want to concentrate in this, okay? Just to show you that we reverse the process every single day. This is what we do in the morning. Watch how we reverse the process at night. We reverse the process to this. At night. At night, we undo the last thing we did in the morning. In the morning, first we put on our socks and then our shoes. At night, we undo what we did in the morning, the last thing. So at night, we take off our shoes. We undo this. So at night, let's undo put by take off. Shoes. And two, let's undo the first thing we did in the morning. Take off socks. And that's how we reverse the process. In the morning, we put on socks first and then shoes second. At night, we take off shoes and then we take off socks. Hey, we can do the same thing here, okay? This function right here is gonna be a function most of the time, not all the time. Okay, so how do we reverse this process? Well, whatever goes inside, this machine is gonna take the value, whatever goes inside this, it goes inside that way, and then it comes out that way. So, this machine is reversing the process to this. So the last thing this did was subtract 3. So the first thing this inverse function or the reverse process is gonna be add 3. So whatever goes inside, the machine takes the value. Let's reverse the process. Add 3, and then before that, divide by 2, and 2, divide by 2. Okay, this should reverse the process to this. So let's see if it works. By the way, well, let's see that first, okay? So 1 goes inside, this is in, the machine takes the value, it takes the value, 1 goes inside, adds 3, what's 1 plus 3? 4. 4 divided by 2 is 2. So a 1 goes inside and what comes out? 2. It worked. Look. So therefore, a 1 went inside and a 2 came out. And these are order pairs for what? For the inverse. Okay? There you go. Let's try it again. Let's try it again. A 3 goes inside, in. Add 3. What's 3 plus 3? 6 divided by 2. What's 6 divided by 2? 3. A 3 comes out. It's working. A 3 goes in, and a 3 came out. That's an order pair for the inverse. Okay, it's reversing the process. Do one more time. Twice. Let's do it 2 more times. A negative 5 goes in. Negative 5. And then what's negative 5 plus 3? That's negative 2. Negative 5 plus 3 is negative 2. And then divide negative 2 by 2. Negative 1. A negative 5 went in. A negative 1 came out. Okay, guys? All right. Give me a second, okay? I'll be right back, guys. Be right back. Okay, so now we said negative 5 goes in. Negative 5 plus 3 is negative 2. Negative 2 divided by 2 is negative 1. Yes, it's reversing the process. So this is what goes in. This is what came out. The last one. Negative 7 goes in. Negative 7 add 3. Negative 7 plus 3 is negative 4. Negative 4 divided by 2 is negative 2. So when negative 7 goes in, what comes out? Negative 2. So it is reversing the process. This is the inverse function. Look, negative 7 goes in. And what came out? Negative 2. Okay. So can we find an expression for the inverse? Yes, we can. The inverse is going to be what? Well, takes the value, add 3, divided by 2. That's the inverse. This works. Watch this. Negative 5 goes in. What's negative 5 plus 3? Negative 2. Negative 2 divided by 2 is negative 1. So when negative 5 goes in, negative 1 comes out. That's the inverse, guys, okay? So what is the inverse doing? It reverses the process. Once you find it, we call it the inverse function. Look what else it does. These are order pairs for the function. 2, 1. What did the inverse do? 1, 2. Reverses. Yeah. It interchanges the coordinates. 3, 3. 3, 3 again. Negative 5, negative 1, negative 5 for the order pair for the function. Look at this. Negative 5, negative 1. It reversed the coordinates. See, negative 2, negative 7, negative 7, negative 2. Hey, okay? Interchange the coordinates. Okay. So that's what the inverse function is doing. Guys, The inverse function reverses the process, okay? I wish I could keep this, but I can't because I need the room, okay? Now, by the way, look, I need to say this. The domain for the function is the range. This is the domain for the function. Domain of f of x is R. This is f of x domain. The domain for the function is the range of the inverse. Look, this is the range for f inverse of x. You see that? That's important to see. Look at this. This is the range of the inverse. So this is f of x range. Let's not forget that, okay? The range for, the range for the function. Did I say inverse? The range for the function is the domain of the inverse. That's right. This is the domain because these are the values that are going in. Look. The domain are the values that go in, okay? So this is gonna be the, what is it, what did we say? Domain. Let me do it in red. This is the domain of f inverse of x. Okay, there we go. Look at this, like it. Okay, I gotta erase this, but at least now we have an idea what the inverse function does. The inverse function reverses the process. Okay, we reverse the process on a daily basis. Look, we do this every single morning, at least I do. Okay, in the morning I put on my socks first, my shoes second. At night, I undo what I did in the morning. At night, I take off my shoes and then I take off my socks. Okay? All right. Now, I do not want to go through all of this just to find the inverse. There is a fast way to find the inverse. And I'm going to show you how, okay? So let me do this. Sorry, but I gotta do it. Don't forget, that's the inverse. I'm gonna show you a fast way to find the inverse of this function. Okay? Erase this. Okay? Don't forget, the inverse takes the coordinates and interchange the coordinates, okay? Okay, so now let's find the inverse. So here's the function. So the function is f of x equals to 2x minus 3. To find the inverse of f of x, let me show you how. To find the inverse of f of x. 1. Replace f of x with y. Two, interchange x and y. And I think you understand why we have to interchange. We have to interchange because the coordinates, when we found the inverse, the coordinates interchanged. That's 2. 3, solve for y. 4, replace y with f inverse of x. Okay, there you go. Okay. These are the four steps you're gonna use to find the inverse. Let's use it on this. Okay. Let's replace f of x with y. This f of x, make it y. Okay, we could do that. So y equals to 2x minus 3. That's what this says. Replace this f of x and I put y instead. 2, interchange x and y. Okay, this y becomes x and this x becomes y. Okay, x equals 2y minus 3. 3, solve for y. Okay, I'm going to solve for, how do I solve for y? Add 3 first. So x plus 3 equals 2y. Divide both sides by 2. So that y equals x plus 3 over 2. Okay. And step 4, replace y with f inverse. This y now becomes f inverse. This y is going to be f inverse of x. X plus 3 over 2. There you go. We found the inverse function. Okay. Remember, we just went through these 4 steps to find the inverse of f of x. Okay. Let's find the inverse of, well, here. Let's find the inverse of the following. Find the inverse of g of x, which equals to 1 over x minus 3. Okay. There you go, right there, look. Okay, no problem. Step number 1, replace f of x, or in this case, g of x with y, okay? This g of x is gonna become y. So y equals to 1 over x minus 3. Step 2, interchange x and y. So this y is x, this x is y. Okay, there you go. Step 3, solve for y. How do you solve for y? Well, to solve for y, we multiply both sides by y minus 3. Okay. So multiply this side by y minus 3, they cancel. Multiply this side by y minus 3, they don't cancel. Here they cancel. Multiply this by y minus 3, and multiply this by y minus 3. So y minus 3 times x equals to 1. Next step, divide both sides by x. Divide this by x, cancels, divide this by x. So y minus 3 equals 1 over x. Add 3. So y equals to 1 over x plus 3 And that is going to be the inverse. G inverse of x is going to be 1 over x plus 3. Okay. There you go. All right. Okay. Let me erase that because I'm going to graph this function and its inverse. Okay? I could have done this one, but it's a little bit more complicated, and so I didn't want to go through that. This one is just easy. I just want you to see it. So watch this. Here's the function f of x. I'm gonna graph f of x. Okay. I should call it y, okay? Let me just call it y. Y. Remember, I think I plugged in 1. I plugged in 1. I think I plugged in 1. No, I plugged in 2. Okay, anyways, let's plug in a few values. Watch this. Plug in 2. 2 times 2. 4 minus 3 is 1. 1 comes out. Okay? Plug in 3, and a 3 came out. Plug in -1. Plug in -1. 2 times -1 is -2. Minus 3 is -5. Plug in -2. -2 times 2 is -4. Minus 3 is -7. So these are order pairs for the function. Okay. What about the inverse? Just interchange them. Inverse of x. 1 and 2. 3 and 3. -5 and -1. -7 and -2. These are coordinates of the inverse. Okay. Let's graph this function, okay? You see 2, 1? 1 and 2, and we get 1. Right there. You see 3, 3? 3 and 3, right there. Okay. You see -1, 5, -1, -5, -1, -1, -2, -3, -4, -5. Right around there. Okay, so we're getting this. It's not perfect. This is the graph of f of x. This is f of x. Okay, what about the inverse? Take the coordinates and interchange. Okay? 1, 2. 1 and 2 right there. 3, 3. 3, 3 right there. Okay. -5, -1. -5, -1, -2, -3, -4, -5, -1 right there. And so we're getting this. And this is f inverse of x. Okay? It seems to me that they are reflections of each other. Yes, they are. Okay? They are reflections of each other. There's a mirror right there. Let me take this off from me. It's a spider web, guys. Okay? So, to graph the inverse, all you have to do is locate the mirror. This is the mirror. Okay? And so, if you look at this mirror, if you look at the mirror, okay, you see the reflection of this. If you're looking at the mirror this way, you see the reflection of this through the mirror, and it's going to be exactly this. That's why they call this the mirror image of that, and that is the mirror image of that. Okay. All right. So that's how you graph its inverse. Just interchange the coordinates, basically. Okay. Now that I show you that, now my question is, can we always find does the inverse always exist? Okay. Well, let me see. Inverse. Does it always exist? And I'm going to show you that the answer is no. Can you always reverse the process to every function? And the answer is no. Answer is no. And I'm going to show you why. Watch this. This is a function. Let's call it function f of x, okay? This is a function. And let's call this function h of x. Okay? And here it is. I have to give you order pairs. 1 is paired with 4. Okay. 3 is paired with 5. Okay. 2 is paired with 4. All right. And -1 is paired with 0. This is a function. Yes, it is. Okay? It's a function. Why? Because there is no y value in the order pairs such that that y value is paired with two different. So there is no x value. Let me say it again. There is no y value paired with two different x values. Is that what it is? I think so. Okay. No, it's like this. An x value cannot be paired with two different y values. That's it. Okay. An x value cannot be paired with two different y values. So this x1 is paired with 4. Is there one again paired with another y value? No. So that's it. This x3 is paired with 5. This x2 is paired with 4. And this -1 is paired with 0. So this is a function. Because there is no x value paired with two different y values. So this is fine. So watch this. 1 is paired with 4. 3 is paired with 5. 2 is paired with 4, and that's okay. That's okay. And -1 is paired with 0. Okay? So that's fine. This is okay. It is a function, okay? You just cannot have an x value paired with two different y values. You can't have that, okay? Let's graph it. All right, we're gonna graph this function, and you'll see that it passes the vertical line test. Graphing the function. X and y. Watch this. 1 is paired with 4. 1, 1, 2, 3, 4. 1 is paired with 4 right there. That point is 1, 4. 3 is paired with 5. 3 is paired with 5 right there. Okay. 2 is paired with 4. 2 is paired with 4 right there. Okay. -1 is paired with 0. -1 is paired with 0 right there. And you see, it passes the vertical line test. By the way, do not connect the points because this is not an equation. These are just points on the xy plane. You don't connect them. It's like a scatter plot. Okay. All right, so it passes the vertical line test. Only one vertical line passes through a vertical line. Any vertical line passes through one point. All right, and that is the definition of a function. It passes the vertical line test. Okay. All right, so it is a function. This is a function, guys. Oh, I didn't. Well, okay, let's not worry about it. All right, let's find the inverse. Find h inverse of x. How do you find the inverse? Remember? Interchange for 1. Five 3. For 2. Zero -1. Okay, that's the inverse. And look, for the inverse, 4 is paired with 1, and 4 is paired with 2. So this is not a function. Not a function. And you can see it, look. 4 is paired with 1. 5 is paired with 3. But then 4 is paired with 2. Look at that. And 0 is paired with -1. This is not a function because 4 is paired with 1 and 4 is paired with 2. This one, and watch, let's graph it. You see that it fails the vertical line test. When you try to find the inverse of this, it's not a function. Okay? Let me graph this inverse. Let me graph this collection of ordered pairs. Four, 1, 2, 3, 4, pair with 1, right there. 4, pair, 5 pair with 3. 5 pair with 1, 2, and 3. 5 and 3. Okay. 4 pair with 2. 4 paired with 2 right there. Uh-oh. And then 0 paired with -1. Okay. 0 paired with -1 right there. And what's the problem? This fails the vertical line test. So, not a function. Okay? But wait a minute. So this is a function, but it does not have an inverse. This does not have an inverse. It does not have an inverse because when we try to find its inverse, that inverse fails the vertical line test. And there it is. So this function does not have an inverse. But you see this vertical line? This vertical line, which is why this is not a function. This vertical line passes through these 2 points. This vertical line is this horizontal line. Those 2 points are these 2 points. So, in the future, we can find out right away if a function has an inverse by a horizontal line test. Look, instead of going through all of this, okay, we found out that this vertical line, these 2 points, are these 2 points. Okay? So instead of going through all of this, you can graph the function and see if the function passes the horizontal line test. Horizontal line test. Okay? And so therefore, we just found a way to determine if a function has an inverse. How? By doing the horizontal line test. Yes. Okay. All right. You guys have this? Okay. This is h of x. It's a function. It does not have an inverse because 4 is paired with 1 and 4 is paired with 2. When you graph it, you can see it. This is 4 paired with 1 and 4 paired with 2. But these 2 points come from these 2 points. Yep. 1 and 4 and 2 and 4 are those 2 points which gave you those 2 points. So this vertical line is this horizontal line. So we don't have to go through all of this. We can just graph the function and see if it passes the horizontal line test. Okay. All right. So watch this. I have to erase this, okay, guys? Okay, watch this, guys. Watch this. I think I just gave you an example of, I think I called it g of x. G of x equals to 1 over x minus 3. Okay? We can graph this. Okay? We can graph this. Here is x, and here is y. Okay? And note, at x equals 3, this denominator becomes 0. So at x equals 3, we have an asymptote. 1, 2, and 3. That's an asymptote. asymptote. Okay? Okay? At x equals 3 doesn't exist. At x equals 4, we get 1. X equals 4. Plug in 4 there. 4 minus 3 is 1. 1 over 1 is 1. At x equals 5, we get a half. And so therefore the behavior is this. Okay? At x equals 2, we get negative 1. Look. 2 minus 3 is negative 1. 1 divided by negative 1 is negative 1. At x equals 2, we get negative 1. At x equals 1, we get negative half. At x equals 0, we get negative 1/3. And so therefore, this is looking like this. It's better than that, okay? It's smoother than that. Okay? So I ask you, does this have an inverse? The answer is yes. Why? Because it passes the horizontal line test. You draw any horizontal line, and that horizontal line is never going to cross the graph 2 or more times. So yes, the inverse does exist. This does have an inverse. We found it earlier, I believe. Okay, how do you find the inverse? We can find the inverse. Look. Find the inverse. And so, to find the inverse, all we have to do is call this y. Y equals to 1 over x minus 3. Interchange x and y. X equals to 1 over y minus 3. Multiply both sides by y minus 3. Y minus 3 times x equals 1. Divide both sides by x. Y minus 3 equals 1 over x. Add 3 to both sides. Y equals to 1 over x plus 3. And that's the inverse. G inverse of x equals 1 over x plus 3. And that's the inverse. And it does exist because it passes the horizontal line test. All right. By the way, here is why they call, this is also called a one-to-one function. One-to-one. Okay? This is 1-to-1 function. And why? Well, because watch what happens. Watch what happens when you graph. Actually, let's find points. For example, for this function, 0, x equals 0 is paired with negative 1/3. Okay. X equals 1 is paired with what? Negative half. X equals 2 is paired with negative 1. X equals 3 doesn't exist. How about x equals 4? X equals 4 is paired with? X equals 4 is paired with 1. Okay? Look, guys. I gave you the example earlier. Watch this. I think I gave you, I said 1 and 4, and I said 2 and 4, and I think I said 0 and 1. Okay, and I think I said something else, 5 and 3, I forgot. 5 and 3, okay? This is a function, but it doesn't have an inverse. It doesn't. Watch this, here's why. Okay, 1 is paired with 4. 2 is paired with 4. 0 is paired with 1. 5 is paired with 3. This function is not one-to-one. It does not have an inverse. One-to-one means it has an inverse. And you know why? 2 to 1. In order for a function to be one-to-one, this cannot happen. Okay? Here we have 1 paired with 4 and 2 paired with 4. That's 2 to 1. So that's why this function is not one-to-one. This function is one-to-one. It has an inverse. One-to-one functions have an inverse. Yes, they do. And here we go. Here, every x value is paired with only one y value. And that's the case here. That's why we call this one-to-one function. This is not one-to-one function. No, it isn't. One-to-one functions pass the horizontal line test. This does not pass the horizontal line test because it's not one-to-one. Okay? Okay, so I hope this gives you an idea. Okay, so one more example, and then we're done with this, okay? So this is one-to-one. So here's a function. F of x equals to x minus 2 quantity squared. You can graph it. It's a function. Here's x. Here is y. This is a parabola shifted 2 units to the right. Parabola, 1, 2, and that's the vertex, 2 units to the right. And then it does this. That's f of x. Note, this is a function because it passes the vertical line test. It's not one-to-one because it fails the horizontal line test. Yes, this one fails the horizontal line test. It is not one-to-one. Not one-to-one function. What does it mean to be not one-to-one? It does not have an inverse. It does not have an inverse. Okay? You can make it one-to-one by limiting the domain. Yes, you can. Okay? All right. So, look. Horizontal line test passes one twice. Twice. Not one-to-one. Mm-hmm. All right. Okay. Okay. All right. Okay. Here is an exponential function, okay? You'll notice that it's going to be a function, exponential. Here it is. Y equals 2 to the x. Okay? Y equals 2 to the x. Let's graph y equals 2 to the x. So here's x. And here's y. Let's plug in x equals 0. Let's plug in x equals 1, 2, and 3. -1, -2, and -3. And you're going to see the behavior of this. This is an exponential function. X equals 0 was 2 to the 0, 1. X equals 1 was 2 to the first, 2. X equals 2 was 2 to the second, 4. X equals 3 was 3 to the third, 8. X equals -1 was 2 to the -1, half. 2 to the -2. What's 2 to the -2? This is 1 over 2 to the second, which is 1/4. 1/4. So this is 1/4. Was 2 to the -3 when you plug in -3 into x. And you get 1 over 2 to the third, which is 1 over 8. So this is 1 over 8. 1/8. So this is an exponential function. Note the power is the variable. The power is the variable. Okay? And the base is the constant. Okay? Let's graph this exponential, good people. Graphing the exponential. Okay? Graph x and y, and you're gonna notice that it passes the vertical line test. So it is a function. Watch this. X equals 0, we get 1. Put it in black. X equals 0, we get 1. X equals 1, we get 2. X equals 2, we get 4. X equals 3, we get 8. 4, 5, 6, 7, 8. X equals 3, we get 8. X equals -1, we get half. -2, we get 1/4. -3, we get 1/8. -4, we get 1/16. -5, we get -4, we get 1/16. -5, we get 1 over 32. And so this is exponential. Note. So for this exponential, it seems to me the x-axis is a horizontal asymptote. It's never going to touch the x-axis. So this is the behavior of an exponential function. All right, let's do it again. By the way, it passes the vertical line test. So therefore, we can change this to f of x. Because it is a function, look, passes the vertical line test. It also passes the horizontal line test. So that means what? If it passes the horizontal line test, what does that mean? the inverse exists. Yes. We're not gonna go there yet. We're gonna go there maybe in the next lecture, okay? But the inverse does exist, okay? So this is 1 to 1. Yes, it is. 1 to 1. And what does that mean? The inverse exists. It passes the horizontal line test. Yes, it does. Okay. You can graph the inverse if you want to. Okay, but we'll talk about that later. Okay. Let's do another one. Here's another one. And this one, let's do it in red. Let's do this one. G of x equals to half to the x. Once again, look. Once again, x is the power and the base is the constant. X is the power and the base is the constant. Here the base is 2 and here the base is half. Look at the behavior when the base is 2. It increases. Let's graph this one and then we'll look at the behavior. Okay? Let's make a table. So here's a table. X and y. Let x be 0, let x be 1, let x be 2, let x be 3, let x be -1, -2, and -3. Okay? If x is 0, what is half to the 0? 1. If x is 1, what is half to the first? Half. If x is 2, what is half to the second? 1/4. If x is 3, what is half to the third? 1/8. If x is -1, what is half to the -1? All you have to do is flip the house. What's the reciprocal of a half? 2, and then change the power to positive to the first. That's 2. What is half when x is -2? Half to the -2. Okay, flip this house, the base, flip it. That's a 2, and change the power to +2. And what is that? 4. So this must be 8. Okay? All right. So let me erase this. And now we're gonna graph this table. Note, base of 2, base of half. Base of 2, this power is x, increasing. Base of half, power of x, let's graph it. If x is 0, we get 1, right there. If x is 1, we get half. 1, we get half, there. If x is 2, we get 1/4. 2, we get 1/4 there. 3, we get 1/8. 4, we get 1/16. 5, we get 1/32. 6, we get 1/64. -1, we get 2. -1, we get 2. -2, we get 4. -2, we get 4. And -3, we get 8. And so this is half to the x. There we go. It is a function. This is g of x equals half to the x. And this is f of x equals to 2 to the x. Note, when the base is half decreasing, the base is 2 increasing. So let's go to the definition of the exponential function. Okay? Exponential function. And here we go. Okay? Here. This is what I'm going to say. Okay? All right, so you saw this. Unfortunately, I need the room, so I'm going to have to erase it. Okay, I'm sorry. Gotta erase it. Okay, just remember, base is 2 increasing, base is half decreasing. Okay. And we're talking about exponentials. And they were both 1 to 1. Yep, they were. And so here we go. So f of x equals the base to the x is an exponential function. Okay? Note, we must say that the base where the base must be greater than 0 and the base cannot equal to 1. Yep. Base must be greater than 0. In other words, this base cannot be negative and the base cannot equal to 1. The base can be a half, the base can be 1/3, the base can be 0.3, the base can be 0.5, the base cannot be -2. The base cannot be -0.9 because the base must be positive. And the base cannot be 1. Okay. And that's an exponential function. I showed you earlier, when the base is greater than 1, okay, remember this? The first exponential function that we graphed, the base was 2. It was increasing. Let's say if the base is greater than 1, then f of x equals b to the x increases. If the base is less than 1, but remember, it's gotta be greater than 0, greater than 0, then f of x equals b to the x. Remember when the base was half? Base half satisfies this. F of x equals b to the x decreases. There you go. Okay. So these are exponential functions, okay? All right. Okay. Remember this function? Remember f of x equals half to the x. Remember that? You can graph it. We graphed it already. Watch this. Here is x, and here is y, and this is decreasing. X is 0, we get 1. X is 1, we get half. X is 2, we get 1/4. X is 3, we get 1/8. X is 3, we get 1/8. X is 4, we get 1/16. X is -1, we get 2. X is -2, we get 4. And so it looks like this. Okay. Well, can we graph h of x equals to 1/2 to the x minus 3? Sure we can. This h of x is really f of x shifted 3 units to the right in the opposite direction. So this is a horizontal shift because it's being done to the argument. Okay, every point of this moves 3 units to the right. Okay. You see this point? 1, 1, 2, and 3. It moves there. You see this point? 1, 2, and 3. It moves there. You see this point? 1, 2, and 3. It moves there. Every point. You see this point? 1, 2, and 3. It moves there. You see this point? 1, 2, and 3. It moves there. Every point moves 3 units to the right. So this is the graph. Okay. Watch here. How do I know I'm right? If you plug in 1, you're going to get 4. Plug in 1 here. What is h of 1? This is 1/2 raised to the 1 minus 3. What's 1 minus 3? -2. You flip it over, a 2, change the power to the 2, and you get 4. You see? It works. Okay. All right. So we can apply the horizontal shift and the vertical shift, okay? To this function, just like before, okay? All right. Let's do an application of exponentials, okay? Applications of exponential functions, okay? Good class. All right, here is an application of exponential functions. Here is an exponential function. The amount equals to the principal times 1 plus the rate divided by n. N is the number of compounds raised to the nt. Okay? This is when you invest P amount at a rate R and compound it n times. Okay? So for example, if you have P equals to $1,000, the rate is gonna be, let's say, let's say 5%, let's say 10%, 0.10. And the number of compounds, n compounds per year, let's say n is 2. I forgot my calculator, guys, so I'm gonna have to use, I can't use my calculator because I don't have it here with me. All you need to do is plug in the values and use your calculator and get the amount. So the amount is gonna equal to 1,000 times 1 plus the rate, 0.10 divided by n, which is 2, raised to the 2 times, oh, and I forgot to say the number of years. The number of years, let's make it 10. Raised to the 10th power. Okay? So the amount you're gonna have in the bank is gonna be 1,000 times this 10% divided by 2 is 5%. And 5% plus 1, right? That's 0.05. So this is 1.05 raised to the 20th. Okay? Use your calculator, I forgot my calculator, and you get the amount. Okay, this is increasing. It's increasing. Why? Because look, this rate divided by the number of compounds is added to 1. So this base is more than 1. So it's increasing. It better be increasing. I mean, if you're gonna invest your money, don't you want your money to increase with time? Of course you do. So this has to be an increasing function, okay? All right. And sometimes, look, you can, this is only 2 compounds per, this is 2 compounds per year. You can change the number of compounds, and the greater the compounds, the more money you're gonna make. Okay? All right. So let's keep the same values, but now let's change the compounds. This is semi-annually, twice per year. How about changing this to monthly? Yeah. Let's do it monthly. Okay. I don't have my calculator, guys, so you're gonna have to use your calculator, okay? So if you do it monthly, let's keep the same amounts. P equals to 1,000. R equals to 0.10. N equals to monthly, that's 12. And T equals to 10 years. Guys, that gives you a better amount at the end of the 10 years. It's going to be better than this one because it's compounded more. How do you get the amount? Let's use the formula. Amount equals to the principal, which is 1,000, times 1 plus the rate. The rate is 0.10 divided by 12, and raised to the 12 times the number of years, which is 10. Okay? Use your calculator, guys. Use your calculator, and you will see that it's better than this. Yep. Better than this. Okay. The larger the number of compounds, the better. You could do it again. Okay, you could do compound. That's 12 compounds per year. That's a monthly count, right? Compounded monthly, I should say. Why don't we keep the same amount, the same rate, the same time, but now let's change it. Let's change N to daily, okay? Daily. So this belongs to this. This belongs to this. And let's do it daily. So P equals to 1,000. R equals to 0.10. And let's change N to 360. That's a nice number. 360. That's like daily, almost daily, right? But that's a nice number. And T equals to how many years? 10. Guys, when you find the amount, this amount is going to be better than this one, which is better than that one. Why? Because the greater the compounds, the better. Okay? I don't have my calculator with me. Okay, you guys do it at home. All right? So amount equals to the principal, which is 1,000, times 1 plus the rate, 0.10, divided by 360, because N is 360, raised to the 360, times what? Times 10. Okay? Use your calculator and you'll realize that this one gives you the better deal. The more the number of compounds, the better. Okay, now, how about if you compound continuously? It's always compounding, okay? Always compounding. Well, continuous compound, let's change this formula. For continuous compound, I think that's the way. I think it needs a U. I think so. All right. Is this f of x equals to p e to the or t? You cannot do better than this, okay? This is the best. This is the formula for the most you can make when investing your money. At your money P at rate R for T years. For example, this one. The P equals to 1,000. We do it in red. P equals to 1,000. R equals to 0.10. N is continuous, okay? N equals to continuous. I'm gonna say like this, look. N equals to infinity, okay? Just to get the point. And T equals to 10. Okay, look. F of X. Actually, I call it f of x, but it should be amount, okay? Amount. And with respect to time, look, time. Okay, so amount is what? Amount equals to the principal, which is 1,000, times E, and E is 2.71. Everybody knows that by now. And the rate is 0.10 times the number of years, which is 10 years. Okay? 0.10 raised E to the 0.10 times 10. And guys, this is gonna give you the best amount you can make for your $1,000, okay? All right. Okay, I am going to stop here, guys.